Yeah, in this video, we will be proving these two sums by Dr. Peyam. We will start with the sum, and then after we have proved this, we can just replace x by pi by 2 minus x to get this series. Let's move on. To prove the first series, we will first go with the sum and then return back to this. So we have sum from n equals to 1 to infinity minus cos 2nx over n. So now for proving this, we need to know that e to the power I theta is just cos theta plus I sin theta. So the real part of e to the power I theta will just be cos theta. We will use this property in this problem. Now we can say that minus cos 2nx is just real part of e to the power I 2nx by n and minus sign. And since this is the summation and this real part function is linear, so we can just take the real part function out of the sum. So this will be real part of summation n equals to infinity minus e to the power. This can be written as I and this 2x to the power n by n. Now I guess if you have completed high school, you should have seen this sum somewhere, that summation from let me write it here as well. Ln of 1 plus x is just summation from n equals to 1 to infinity and x to the power n by n and negative 1 to the power n plus 1. So you should have seen this sum, and if we have 1 minus x over here, so this will be summation from n equals to 1 to infinity, and here we will have minus 1 to the power n x to the power n times minus 1 to the power n plus 1 by n. Now since we have minus 1 to the power 2n plus 1 and 2n plus 1 is odd, so we will just have negative 1 times x to the power n over n. Now we have the same sum over here, just that in place of x we have e to the power I to x. So this sum should be real part of ln of 1 minus x, and our x is e to the power I to x. So this sum is just this from the property of logarithms. Now the problem now is to find out what is the real part of a log function. Now in complex analysis, you probably would have heard how we deal with these problems. Let me show you here. Now to find the ln x, real part of ln x, what we can do is for this, we know that if x is a complex number, we can write it as r times e to the power I theta. If x or it's z, let's say if this was z instead of x, because z is the more appropriate convention for a complex number. So if we had a z over here being complex number, then z is in the form r e to the power I theta, where theta is its argument, that is angle made with real part axis, and r is its magnitude or length. So for a real complex number z, we can write z like this, and then this will be real part of ln of r plus ln of e to the power I theta. Okay, so then we will have real part of ln of r plus this will be I theta. So in fact the real part logarithm of z uh, can be, so in fact logarithm of z has real part of as ln of r and imaginary part as argument of z. Okay, so now we can just take the real part from this because we have the real part function over here. So ln of r is the real part of logarithm of z, where r is the just the length of complex number and is denoted as modulus of z. So now we know that real part of logarithm function is just the logarithm of the modulus of the complex function. So now we just apply the same thing here. If we, I will drop this now. Okay. So now this will be a real part of ln of. Now we can write e to the power I to x as cos 2x and plus I sin 2x because of negative sign it will be minus I sin 2x. Now this will be real part of ln of for we have 1 minus cos 2x in the real side and minus sin 2x in the imaginary side. Okay, and now if we have to find the real part of the logarithm of this function, we know that this is just logarithm of the modulus. The modulus will be root under from here it will be 1 minus cos 2x whole square, that is 1 minus 2 cos 2x plus cos square 2x, and from here it will be sin square 2x. Okay, now we have this, and now this will be ln of and square root. This is just 1, so this is 1 plus 1 2 minus 2 cos 2x, and this is ln of we can take 2 common and we have 1 minus cos 2x, which is 2 sin square x. 2 sin square x, this is a simple trigonometric property, and then we have ln of this is 2 sin x. Okay, so we have derived ln of 2 sin x over here. So now we have derived that summation from n equals to 1 to infinity minus cos 2nx by n is simply ln of 2 sin x. Now we will use this for the other property. Yeah. And now we'll try to derive the second one. Now since we have the first one, what you can do is you can just substitute x by pi by 2 minus x, since that will change sine into cos, and so we have summation from n equals to 1 to infinity minus cos 2n of pi by 2 minus x and then over n. Now this will be n pi. Now we will have 2 cos x equals to summation from n equals to 1 to infinity and negative sign over here, negative 1 over here, and then this will be cos n pi minus 2nx. Okay, and cos n pi minus 2nx is negative 1 to the power n times cos 2nx. This is because when n equals to 1, the value will be minus cos 2nx, and when n equals 2, it will be cos 2nx. N equals 3 minus cos 2nx, so we have introduced minus n to the power n over here, and then over n. Now we have the final step to compute this problem. So it is ln of 2 cos x is equals to summation from n equals to 1 to infinity and then minus 1 to the power n plus 1 cos 2nx by n. So that was what to be proved, and we have proved this. We have proved both the sums And thanks to Dr. Peyam for the idea. And thanks to you watchers for watching till the end. Do share with your friends this amazing result. Personally, this is my favorite song, and I believe it is of yours too. Share with your friends. Thanks for watching.